So let us see introduction to Geographic Information Systems, that is GIS. So exactly we live in two worlds. One is the natural world, which was made by the Almighty, and it is self-regulating. You don't have to do anything. Everything is regulated by itself. But there is one world which is constructed world, which we have constructed, and we live in this constructed world. So this needs some management. Okay, they are increasingly in conflict because self-regulating and managed, we are making some changes that may affect this self-regulation. So seeing the world is like this through some view, and managing places, so seeing the whole world in form of patterns, linkages and trends, while managing places involves watersheds, communities, neighborhoods and districts. This is just an example that what is the percentage of seropositive pregnant women at Kenyan surveillance site. You see that this is an area, and the explanation is through some map. Okay, this map, by just looking at some density values, some legends, this data on just a screen or a piece of paper, you can very well find and make decision depending on what data this is, right? And if we want to abstract the real world, this is the real world. Now you have some district, you have made the districts, you have made the parcels, you have made the streets, and these are the land use. So these are the extraction of the area which you have developed, you have made, right? So now let us talk about GIS. Before going to GIS, I need to show all those things, because a GIS is a computer based system which includes software, hardware, people and geographic information. So a GIS can or should create, edit, query, analyze and display map information on the computer. Wherever we are talking about spatial data, location based data. So this GIS, let us take one word by one. This is geographic. So 80% of the government data collected is associated with some location in space. They involve geography. Information is the attribute, the subsidiary, the ancillary, the characteristic, and that can be used to symbolize and provide further insight into a given location. Then system, a seamless operation linking the information to the geography, actually which requires this system means you have hardware, network, software, data and operational procedures. GIS is therefore not just a software, it is not just making of maps. So who uses GIS? Everyone uses GIS. If you have geography in mind, like you want to go from place A to B, then you have something or some road or some network in your mind, you have GIS in your mind. So international organizations are using it, private industries are using it, government is using it, NGOs are using it, academic and research institutions are using it. All those which are involved in some sort of studies, research, decision making, planning, they ought to use GIS. What can you do with GIS? What are the capabilities of GIS? The possibilities are unlimited. Right from environmental impact assessment to resource management to land use planning to text mapping to water and sanitation mapping, transportation routing and more. These are dot dot dot, it includes a lot of them. GIS, how does it work? GIS data is essentially a spatial or geographically referenced data. So this might be a reference that describe a feature on the earth using a latitude and longitude, a national coordinate system, an address, a district, a wetland identifier, or a road name. Okay, GIS can do all these things. It includes all those things. Geography and then database. GIS is capable of storing, or it stores information about the world as a connection of thematic layers that can be linked together by geography. These thematic layers means the layers or the superimposition based on some theme. So GIS provides data integration. These are all there. You talk about roads, land passed, population, utilities, landmines, hospitals, refugee camps also, wells, sanitation. And GIS has vectors, rasters, surveys, network, 3D objects, addresses, CAD drawings, terrain, attributes, annotation, dimensions, images, all these things, these are all in GIS. GIS just is not making a map, you have a software of making map. No, it is able to show, visualize, analyze various data from different sources like CAD drawings. Even if these CAD drawings are not geographically inclined or aligned, they can already be a part of GIS. Addresses are shown, 3D objects is shown. You have a terrain, you have 3D, you have tin, DMs, all is there. Now you can annotate it, make a report out of it, report generation can be done. Okay, so two fundamental types of data are there, which are the basic backbone of any GIS system. First is vector, a series of XY coordinate. These are XY coordinates, or you say point feature, line feature, or polygon feature. Each has different points of XY coordinates. For discrete data representation, these point line polygons are used. While raster is a grid or a cell. So for continuous data such as elevation, slope and surface, we would require a raster. So a desktop GIS should be able to handle both vector and raster data effectively and efficiently. Data representation. This is raster, see this is gridded. Vector, see this is in point line polygon form. This is the real world. You have a base image, you superimpose, you merge these images on it, you will see a realistic view of actual earth. There are also different functionalities and features of GIS. Produce good cartographic products, GIS does that. Generate and maintain metadata, the data about the data, and the use in sharing of geoprocessing models, also managing data in a geodatabase using data models for each sector. So we have certain processes, these are the tools, these are the derived data. So having a GIS software does not make a cartographer. What cartographer does it essentially help it. So good to know something about these issues when creating a map and doing spatial analysis, because cartography is an important aspect of GIS. So all data has, or map has, scale, resolution, projection, base cartographic principles, and regarding design, digitalization, etc. So this GIS is rapidly evolving, right from the projects to systems to networks to societal. These are in the phase-wise integrated, coordinated, cooperative and collaborative. This is how it is rapidly growing. Now we have societal values, societal regime dependent on our GIS. Now why GIS? You need to make certain decision you make to uplift somebody's life, people's life, or solve certain query, solve something on the computer, on the system. What is the problem statement? Formulate the question, observe, acquire data, analyze it, seek solution, mitigate and change. This is how we start with a question and solve it via GIS. Spatial data infrastructure, this is SDI. This is the technology or policy or standard human resource and related activities necessary to acquire, process, distribute, use and maintain and preserve the spatial data. This is a part of SDI is a part of many nations' e-government strategy. You can go to GDSI and formally understand about what is spatial data interface or infrastructure. So this is the geographic knowledge, this is the world. World provides us the inventory and geographic knowledge provides the decision support, and essentially it helps the citizens. In World Summit on Sustainable Development 2002, it was said that promoting the development and wider use of Earth observation technologies, which include satellite remote sensing or global mapping and GIS to collect quality data on environmental impacts, land use and land use changes. See, this is the diagram, or this is a view of how GIS is changing roles and solving those questions on your PC. These are the poverty indicators. These are the overlay analysis of poverty in Mexico City. We have a poverty map, lack of housing, lack of drain net, lack of potable water, low income, low education level, unemployment. Combine them all and this is in a view. Government can see it. Government can make decision on it. Government make policies on it. Now this is the monitoring of fair trade, local banana farmer. This is also one of the example that on certain things the economy is dependent in certain country. So to make them more efficient and to finalize the policies depending on the data available, GIS can be used. GIS for planning and underdeveloped areas, the tale of two cities as it was formerly called, the formal and the informal. So both deserves the GIS. Complexity is not an excuse. This is, see, the GIS for planning underdeveloped areas, and GIS is not this is misunderstood. The GIS is only for developing countries or underdeveloped countries. No, though GIS has an important role in these countries, but as far as developed countries is also there are other things which involve GIS, which are much more important, much more real time, much more realistic. So see, this is a lack of public open space. Barrios have a percentage of public space between 5% to 10%, this area, and in the average city total space constitute over 30% of the total space, right? So the absence of adequate infrastructure, urban furniture and maintenance, which combines produces unhealthy and insecure conditions, right? See, this is the transformation capacity which is determined through a detailed review of the build form. The GIS for planning underdeveloped areas. So dealing with a complex morphology requires understanding of the existing physical order, identifying the social order confirmed by the community ties and with no physical evidence. Also, this is one of the example of planning underdeveloped areas, analysis of the social network and the community ties. Sustainability is preserving the small social groups. This is the social network which is topology related. So achieving this MDGs requires all of us, means may it be government, may it be people, may it be the planners, may it be the architects, may it be the engineers, everybody is required. Thank you so much. Hope you got an overview what is GIS, why it is important, not just for specific countries but for entire world. Thank you so much.